Um, Hello, everybody, and thank you for being here. The topic of the webinar is to see how and where Dapr and Kubernetes differs, and more importantly, to see how they complement each other. And if you ask me, what's the purpose of this comparison? Aren't these, comparing like apples and oranges? And I would say yes. The answer is yes. But these are two projects that serve different purposes. But the goal of this presentation is really to learn by comparing them. So if, for example, you know about Kubernetes, but you haven't tried Dapr yet, you can see what are some of the gaps in Kubernetes and how can Dapr complement those. So keep this in mind throughout this presentation, and let's see if we can, what we can learn by this comparison. To do that, right, we will look at a number of capabilities of both frameworks. We'll see how far we can get in an hour. I'll try to go quickly and cover most of these areas. And if you're wondering, why should I cover this topic? So right now I'm a product manager at Tigris, and at Tigris we are amongst the most active contributors and maintainers of Dapr project. Before that, I was a consultant architect, product manager at Red Hat, where I work a lot with middleware integration space. I have been a committer for Apache Camel. I've used Kubernetes. So I do have some opinion about Dapr, Kubernetes integration and middleware. And that's what I'll try to share in this presentation. So let's start with a few Dapr concepts. Really, it's not a presentation to learn Dapr, right? I will not go into the details, but I want to explain two Dapr concepts only that I will use throughout this presentation. And the first one is the Dapr APIs, which in Dapr world, they are called the building blocks. All right, yeah. So Dapr is not a platform that you deploy your application on, right? Like Kubernetes, right? It's not also a framework that you plug in your classes and libraries. It's not a library that you include in your app, even though it has a library, a client-side library that you can use from different languages. But Dapr is, in a sense, a process that runs next to your application, and you call Dapr APIs from your application. If you're wondering why would I call Dapr APIs, because they offer capabilities such as service invocation when you want to do service discovery to call some other services. If you want to access a different type of state stores, if you want to publish or consume messages, right? If you want to use workflows, get secrets and configurations. So Dapr has all of these APIs, and you access those from your application from HTTP or gRPC. In similar way to Kubernetes, Dapr supports different languages, and it doesn't care what's the shape of your application, whether it's a monolith, microservice. It kind of have same mindset as Kubernetes. The second and last concept I will introduce here is the concept of components. And you can think of these almost like the implementation that are backing your APIs. For example, the PubSub API can be backed by Kafka, RabbitMQ, SQS, SNS. The key value API, the state store API, can be backed by Redis, by Postgres, by AWS DynamoDB. And as a user of these APIs, the only thing you have to do is to configure the component with the configuration file. And if you're coming from Kubernetes background, if you know Kubernetes, the good things are that these configuration files, they are YAML, and they are same as the Kubernetes CRDs. And it doesn't matter if you're using Dapr on Kubernetes or outside, it's the same component file, YAML file in the CRD format. How do these two concepts come together? So here we can see that on the right-hand side, I have a Redis component. It has a name, order store, and you can see it has a type. It's which is the state API, and Redis is the actual concrete implementation. And there are some details on how to connect to Redis. On the left-hand side, you can see the Dapr state API. This is how you would use the order store only by referring to its logical name and performing different operations. what about, if you want to swap to different type of state store implementation? The only thing we have to do is change the component definition, so the implementation configuration, and the API doesn't change at all. But this alone, abstracting the different infrastructure is not really, I would say, a strong enough reason to use Dapr. There are many other reasons which we'll see throughout this presentation. And so let's go through this. I'll try to cover, I'd say, around 10 areas. The first one is the application lifecycle. So there are different ways to run workloads on Kubernetes. You can run an app as a demo process, one on a node, which is not on this picture. You can run a pod, an app until completion as a job, as a periodic job. For example, you can run it as a stateful process. You can run it as a serverless process using Knative, right? A process that scales down to 0 or scales up rapidly. Or the most popular one, you can run it as a stateless service. And this is really what Kubernetes is made up for and excels at, running different type of workloads and managing their application lifecycle. What about Dapr? I would say the first thing to use Dapr on Kubernetes is you have to install Dapr, right? You can use the Dapr CLI to do that, which is good for development because it can install Dapr on Kubernetes with a single command. You can use Helm or use an operator on Operator Hub, for example, if you're doing it on OpenShift, or you can use the Grid Conductor, which is our managed service that helps you install, upgrade, manage Dapr on Kubernetes. Now, once you've done that, you get the Dapr control plane, which really integrates the Dapr sidecars with the rest of Kubernetes. And the sidecar in apps is this way your application workloads are. And we said that the sidecar is running side by side with your application as a separate process, but there are different ways to do that. The most popular one today is the sidecar model. So if you are running an application as a deployment, as a stateless application on Kubernetes or as a stateful, so it doesn't matter. The way to add Dapr as a sidecar is you just annotate your Kubernetes resource, and the Dapr injector will make sure there is a sidecar next to your application. And this deployment has a number of advantages, right? Each application instance, each replica basically gets its own sidecar, right? Which minimizes the risk of any kind of resource contention, any kind of security breach between instances, etc. It decouples the life cycle. So if you restart a replica, it doesn't affect the other replicas. But that's not the only way to run Dapr. In situations where really, this kind of a tight isolation is not crucial, you can use the shared Dapr model, and this will give you basically quicker startup time and shutdown time, because your application now can be a pod on its own without a sidecar, as you can see on the diagram, and Dapr can run as a daemon set or as a deployment. The important thing to keep in mind here is, I would say, is that in this case, Dapr is not shared with all the applications, but rather it's shared between the different replicas, between the different instances of your application. And this has, certain trade-offs. For example, your application now can be a function with Knative or open functions, and there are examples of using Dapr shared with those. And your application, can start up quickly. The sidecar will be already running, and you can start interacting with it. You don't need to have a resource for every replica for the sidecar, right? And updating, restarting the Dapr sidecar doesn't affect your application. These are some of the advantages, and on the other hand, you can suffer from noisy neighbor, shared downtime, or you may have to scale the Dapr sidecar when your applications are scaling. And there is more, right? For example, if you're running a job on Kubernetes for your application, and a job is basically short-lived workload that runs until completion. And if you inject a sidecar there, the job won't complete unless the sidecar is shut down. To do that, what you have to do is, from your application, when you complete the work, you have to tell the sidecar to shut down. That's it. As you can see on the right-hand side, if you are using, an SDK, Dapr SDK, you can tell it to shut down, and you can use Dapr in short-lived tasks. This is just a summary from the different kind of deployment types. What we are not covering here is there is also even a serverless managed version where you can use Dapr as part of a cloud service. So to sum up, I would say Kubernetes manages different heterogeneous workloads from different languages. And on Dapr side, Dapr really doesn't manage application lifecycle at all. It doesn't have a say, but it adapts to different type of application lifecycles nicely on Kubernetes. So let's move on to second point, which is the health check. And health checks in Kubernetes is the way to address, really the challenge of how do I find the state of an application health without knowing the exact implementation? How do I find out externally and uniformly? And the important thing is that these health checks usually, to be reliable, they have to be performed from outside of the application rather than being from the application itself. Otherwise, if the application is unhealthy, it might not be able to report its health. And in Kubernetes, there are 3 probes today. There were 2, and now we have also startup probe. And the important thing for this presentation is to see what is the corrective action taken by Kubernetes. For example, if a startup probe fails, your pod will be restarted, right, until it starts up successfully. If a readiness probe fails, that pod will stop receiving traffic from the service. That's the only side effect. If your application is not using service, readiness probe will not have any effect. And if liveness probe fails, your pod will be restarted again. Actually, the container will be restarted. What about Dapr in this case? So if you're injecting Dapr with the Dapr control plane, the Dapr injector will set up the health check configurations for the sidecar. So the kubelet can check the health of the sidecar. But in addition to that, from your application, you can also check the health of the sidecar. This can be useful. For example, maybe your application has startup and it needs to talk to sidecar to get some kind of a configuration or secret from an external store. All right. In that case, you can check the health of the sidecar. And there are 2 different endpoints. The health one will actually records the full health of the sidecar plus the fact that it can talk to your application successfully, or you can just call the outbound endpoint, in which case it doesn't have to verify that it can talk back to your application. It just verifies that the sidecar has started, it has connected to the external backing services, the components. And in case of looking up a secret, that would be the right endpoint to check. Now, interestingly here, Dapr can also perform health checks to your application. And you can see here how to do that. Basically, you can add annotations into your application deployment, telling it how Dapr should check the health of the application. And this one is really useful in situation where your application has outgoing connections. Imagine when your application is using Dapr, which connects to a message broker as a subscriber to consume messages. There is no way today in Kubernetes to tell that an application is healthy in that case to stop this kind of outgoing traffic. So if the application health check fails, Dapr will stop all kind of subscribers to message brokers. It will stop the input binding. So again, pulling work from external stores, and it will short circuit any kind of service calls. So if I were to sum up, right, Kubernetes will reboot your app, or it will redirect incoming traffic to health instances, but Dapr can complement that. In this case, Dapr can actually stop any kind of almost like outgoing connections and stop pulling for more work, whether that's from message queue or some kind of other connector. So moving on, once we have applications that are up and running, that they are healthy, the next thing they want to do is communicate, talk to each other. And let's look at synchronous interactions. For this purpose, Kubernetes has the service resource, right? And the service resource really helps to expose a network endpoint for your applications, whether they are running as pods on the cluster or some external applications. Now, depending on the type in the service definition in the YAML file, depending on the kind and the spec, there are probably 7, 8 different types of services on Kubernetes. Here, the first three I have are with kind, node port, load balancer, ingress. And the common thing among those is these are for getting external traffic into the cluster. And in this area, I would say Dapr doesn't provide anything, as it's not really an API gateway, even though it can integrate with the gateway. So you can have a gateway with Dapr sidecar and give your gateway ability to discover services if that's what you want. The other service types in Kubernetes are, for example, for discovering or pointing to external services, whether that's by IP or DNS. And Dapr also can do that with its HTTP endpoint resource. But the most popular one, the most commonly used in Kubernetes is the internal service discovery between the pods, the cluster IP type, right? And this service resource really helps to do service discovery because the pods are typically ephemeral and their IP changes, and it helps to do load balancing using the health checks, and it lets you use DNS to do that. But it lacks resiliency features such as retry, circuit breaking, timeout. It doesn't offer network metrics or traffic encryption. And this is what Dapr can give you, right? If I have a service, a shopping cart that wants to call checkout service on the order method, the way that would look with Dapr and the service invocation API is the shopping cart, rather than calling checkout, it would call the sidecar. See, now it calls localhost 3500. That's where Dapr is running. In this case, it's calling the invocation API, and it's of the checkout application. That's the target application. It's calling the order method. What Dapr will do in this case, it will use service discovery on Kubernetes. That will use Kubernetes service discovery behind the scene. It will encrypt the traffic. It will check the access control permissions. It will call the target sidecar, and which will in turn invoke the order method on the checkout service. While doing that, you get the full observability, resiliency, access controls, all kind of cross-cutting concerns will be covered. And what about if you don't want to use the Dapr notation of service invocation, basically the URL on the bottom left with the invoke, checkout method, etc. In that case, you can still call the sidecar, but you can give the app ID as the header, so that can work in situation when you cannot change the application, but you can just change the URL. And with this, you get full location transparency, right? Which can be based on Kubernetes or something else, such as HashiCorp console or relational database. You get additional access control policies I'll cover further, and you can also plug in other custom interceptors, which in Dapr world are called middleware, to perform some transformations or perform authorization, etc. One thing we didn't mention earlier is that Kubernetes can also do, in a way, access control, right? Kubernetes has namespaces, but namespaces are primarily for allowing you to group different resources. Pods in one namespace can talk to any of the pods in a different namespace. And this has, certain security implications. And the way to address that in Kubernetes world is through network policy. In our example, the way to use that would be, since our shopping cart wants to call checkout service, we can have a network policy which has a pod selector. That's the caller. Sorry, that's the callee, the checkout service, which is mapped by label, and it accepts ingress calls from basically the shopping cart, right? And the Kubernetes network policies, they operate at layer 3 and layer 4, so they operate at TCP/IP. So you can do network isolation really between pods or pods and namespaces. You can use namespaces, IP ranges, port numbers, and at that level, really. And if you look at what Dapr has in this space is what's called access control. So access control is the authorization mechanism for service invocation in Dapr. To understand that, I think the first thing to understand here is that Dapr has the concept of application identity. So each application in Dapr has its own identity, which is backed by SPIFFE ID, which is then attached to its TLS certificate. And you can define granular access controls at layer 7. And what I mean by that is basically you can use the different HTTP verbs, paths, or the gRPC operation to specify what kind of access your application is. In the example I have here is a configuration file which will be used by the checkout service. So that's the callee, the target service, and it's basically denying access from all application at first through the default action, and then it defines only exceptions. So only the shopping cart can call the order endpoint through the post HTTP post operation. So it's much more granular, and it means no other application from that namespace or from an IP range can call anything else on this application. Now, keep in mind that this is only in the Dapr world, so an application could, for example, if you don't have a network policy that accompanies this, can skip Dapr and can still call your application if you have other applications. Now, this kind of raised the question, is Dapr then a service mesh? Because what we've described here is very similar to authorization policies in, for example, in Istio, right, or other service meshes. And the answer to this question really depends on what's a service mesh. And today, service mesh is most commonly defined by capabilities such as traffic encryption, through NTLS, network metrics, resiliency, network resiliency, specifically distributed tracing, traffic routing, traffic splitting, this kind of capabilities. And you can see that the Dapr service to service API, service invocation API overlaps with some of those, except the ones around traffic routing and traffic splitting. So in that regard, you can say Dapr performs some of the service mesh capabilities, but Dapr has many more APIs. So, and it's much more closer for developers, as developers and the application have to call the Dapr API. It's not a transparent proxy or a sidecar. The URL here provides some more details around this question, if you're interested. So to sum up, from service interaction communication point of view, specifically synchronous, I would say Kubernetes only gives you discovery and load balancing and very low-level network policies, and Dapr kind of gives you resiliency policy tracing, much more granular layer 7 access control policies, and pluggable middleware and service discovery options. Right. So after synchronous interactions, let's look at the asynchronous interactions. What we can use to create event-driven applications. And if you look at what Kubernetes gives us to create event-driven applications, there isn't much today. But actually, if you look at the broader cloud-native ecosystem, CNCF, there are many projects that helps you to create event-driven applications. For example, there is a Streamzy project that helps you manage, operate Kafka. There is a Header that helps you scale applications, including event-driven applications, consumers based on queue depth. And there is Knative that helps you, have basically it helps you connect producers with consumers using some kind of message broker and messages in cloud events. And in that regard, I would say Dapr is closest to Knative eventing from this aspect. So again, we have our checkout and in this case, shipping application now. And let's imagine they are trying to interact with each other asynchronously using some kind of message broker. It doesn't matter what's the exact type of the message broker. And it's quite similar picture in this case, the checkout service. In order to communicate with shipping service, would use the Dapr PubSub API. The interaction is very similar. The application is actually calling localhost 3500. So that's the sidecar, but rather than invoke, this time it's calling the publish API. And it has the name of the broker, the component name, and the name of the topic order messages. When that call reaches the sidecar will deliver the message to the message broker by checking access control policies. There are access control policies for PubSub. In this case, it will check whether this application can. There are different mechanisms, but we can say that it will check whether this application can publish to this specific topic as the most granular level, and that's independent of the actual broker implementation. It will again apply resiliency policies if that connection to the broker fails. It will wrap the message in cloud events and deliver it to the message broker. On the consumer side, the other sidecar will get the message and deliver it to the application. And you get all the cross-cutting concerns covered, such as observability, resiliency, and tracing. Here I have a few examples how that interaction might look like. Publishing is a very standard way of publishing to any kind of message broker, where you have your Dapr client from the SDK and you publish to a specific topic and a message broker. On the consuming side, you can consume either by starting an HTTP endpoint and let the Dapr sidecar to push each message to your application, more like Google PubSub, right? Or one of the new features, streaming subscription, you can have your application open up a connection to the sidecar, not to the broker, to have bidirectional streaming connection, and the sidecar is delivering the messages to your application. So two different ways to consume. And the things you get here is that you get abstraction over the message broker. So in a cloud native way that's abstracted, you can still perform things such as content-based routing, filtering, if you don't want to consume all messages or you want to route them to different endpoints. You can even have something like the aggregator splitter patterns by aggregating, batching, and aggregating messages. You get dead letter topics, access control per topic, message expiration, and all of these features are independent whether the message broker can provide these features or not. The sidecar can make sure that these features are working as expected. So if I were to sum up from event-driven interaction point of view, Kubernetes doesn't give us anything, but there are other projects in the Kubernetes ecosystem that gives us the building blocks, and Dapr specifically gives a very good abstraction on top of message brokers and different ways of message guarantee, resiliency, access control, etc. So continuing at the fifth point, state management. The most common workload type on Kubernetes today, I believe that's the stateless workloads, some kind of a microservice, let's say. And the key thing about the stateless service is that it doesn't maintain any state internally within the instance. And in Kubernetes, that means the container doesn't store any state in memory or in its ephemeral storage, right? And instead, it stores that state into some kind of external store, such as file system, database, etc. And if you ask me what does Kubernetes gives here, we see in the service abstraction, we talk a little bit about the stateless workloads, the replica set deployment, where it can start multiple replicas of the same service that are identical and ephemeral. And Kubernetes also gives persistent volumes, which is an abstraction over storage. And it has a way to give that to the containers, to the pods, using the persistent volume claim. And this indirection basically helps you to decouple the lifecycle of your application and the storage. And there are different ways to access that storage. I've listed here the different access modes, like read, write once, which means storage will be mounted to a single node. Read-only many, it will be mounted to multiple nodes, but only for read-only mode. There is read-write many, which means the volume will be mounted to many nodes, both for read and writing purpose. But notice that these are actually telling you how many times the volume can be mounted to a node. So it's not about the pod, but it's about the node. And on that node, there can be multiple pods that use that storage. And that's why one of the latest type here was that was introduced is read-write once pod, which guarantees that only a single pod can access the volume. Now, even without this access mode, if you look into Kubernetes documentation, you will see that a big disclaimer that says, these access modes do not enforce any kind of write protection to the storage system. So you may think that these different access modes give you some consistency and isolation guarantee, right, which can help you avoid some conflicts when you're writing to that volume by multiple writers. But that's really not the case. So really, there isn't much from storage point of view that Kubernetes gives to application developers, in my view. And what Dapr has in this space is the state store API, which in reality is a key value API. And here I have an example where the order service is using Dapr, the state store API. You see it localhost 3500, state API, and my state store, which is the name of the component. It's kind of writing to that state store a key and a value. And that state store behind the scene can be one of many implementations. Again, two examples how you can use a read operation from my state store, how you can read order one key, or how you can write to the same state store using Dapr APIs. And the good thing here is that if you need a key value API, Dapr will abstract the different implementations, so you can swap. And if the supported implementations, it will give you certain concurrency and consistency guarantees. Whether you want first write win or last write win from concurrency point of view, if you have concurrent writes, or if you want to enforce certain consistency, from consistency, eventual consistency between the replicas, you can have, when you are interacting with that state store, you can enforce transactional behavior, so you can combine multiple operations in a single transaction. You have the cross-cutting concerns of resiliency and observability. You can enforce time to live. So when you write to your to a state store, regardless whether that state store have time to live feature or not, Dapr can make sure that the requests you write are not readable after they expire, for example, or you can encrypt the data before writing, etc. And there is an access control as well. In this case, the access control is not per operation, so you're going to give an access, only read-only access, for example, to an app, but you can give access to specific apps. That's what you want. Now, one of the good things I personally like around here is we've seen the PubSub API, we've seen the state store, and now we can see that there are other capabilities which are built on top of each other by combining those. And the outbox pattern is an example of that. Basically, the idea of outbox patterns is to let you write to some kind of state store and propagate those changes transactionally to other services, typically using some kind of message broker. And this is what Dapr State API allows you. Basically, if you're using Dapr State Store API to write to some kind of a key value store, in this case, I have service A that is writing to state store, right, which can be one of many, whether that's relational database, and if the transactional database is there, Dapr will make sure that those changes are also propagated to a message broker, one of the available PubSub message brokers. And all you have to do in this case to enable that feature is, as you can see in the component definition of the state store, you're telling to enable the outbox pattern, and you're telling which message broker which topic these changes should propagate to. It's that simple. So if I sum up from state management point of view, the key differences, I would say Kubernetes, gives you durable storage. It gives you abstraction over that storage, but the only way to access that storage is through the file system interface. Whereas on Dapr, the access way is more through the key value API with powerful features on top, such as outbox, resiliency, TTL, and others on top of different storage providers. That's the main difference. So we've passed halfway through, so let's continue. The next one is stateful workloads. And when we talk about stateful applications, it's really stateful application means different things to different people, to different projects. In Kubernetes, when we talk about stateful workload, it's typically defined by the stateful set resource. And what that gives us is features such as persistent identity, right? So if you have a distributed stateful workload on Kubernetes, that means the application is stateful and there are multiple replicas, but contrary to deployment, where each replica is identical and ephemeral and can be replaced, in a stateful set, each replica has its own identity and it has its own stable network address. So you can actually call specific instance of that stateful set, specific replica. In addition, it has its own, it can have optionally its own storage, which is different than a deployment persistent volume. Here, each instance has its own volume. The other thing is that these instances also have certain order, and that order matters during startup and shutdown. So there is an ordinality. So these are really what Kubernetes gives us when we're talking about stateful applications. Yeah, Kubernetes looks at stateful applications more from process point of view, networking address, and file storage. And I'd say when a developer talks about stateful application, that typically really means some kind of a stateful, business process, some kind of a business logic that is implemented with some kind of a workflow or some kind of a service interaction, stateful service interaction, like the Saga pattern. And in Dapr, these are done through the Dapr workflow API. And Dapr workflows are really, they are functions that you write, you define in your applications using the Dapr SDK. And these functions are executed in a particular order with specific guarantees. And what happens is the Dapr workflow engine, which runs in the sidecar, it takes care of persisting the state of the overall workflow execution, making sure how far it has gone, making sure the tasks are scheduled properly among the instances. If they are failing, these are retried, etc. So with Dapr workflow, developers define the workflow using the codes, using a language they prefer, and the engine runs those inside the sidecar and orchestrates. And that lets you implement patterns, workflow patterns, right? Chaining applications, etc., which I'll show shortly. So this is one of those patterns, split synchronize, where a work can be basically can be parallelized into three branches that can be executed in parallel. As you can see here, I have three tasks, and then they are all aggregated into a single result. So the workflow will wait for all three to complete to aggregate the result in some way, and then the workflow is finished. There are many other patterns, right? Sequence, for example, is when you want to execute tasks sequentially, and one task is only started after the previous one have completed successfully. You can have an external trigger that sends a signal to your workflow. You can schedule workflows with a timer, etc. So they are well-known workflow patterns. But the important thing here is that these workflow patterns are typically implemented by developers in the application using some kind of a programming model provided by the framework. So to sum up, stateful workloads on Kubernetes, these are really coarse-grained process-level orchestration, like in what order the processes are starting up, shutting down, what kind of storage gets attached, and what's the address of these instances. Whereas in the Dapr case, when we talk about stateful workload, stateful application, it's more about the business processes that the developer implements within the applications. And this state gets stored in some kind of a state store, and the execution has certain guarantees to complete from where it's left off. That's the main difference. So that takes us to the next point, which I call tasks. You can think of these more like finite jobs that are executed until completion. And this in Kubernetes space, this is handled through the job abstraction. On the left-hand side, I have a job, right? Job definition, which runs a container. And I would say this is probably the smallest unit of work you can run on Kubernetes, right? Maybe you have a container that will run one time, and it will run until the completion. When the container exits with success code, the job is done. Otherwise, the job is not done. And what Kubernetes will do here is that it will make sure that this job is scheduled on a node and it has executed and completed successfully. Here are some parameters you can control. For example, right, you can control how many times it should run, and the parallelism. Now, if I continue, what is the smallest unit of work in the Dapr world? I would say that's probably an actor, and smallest unit of task. And you can think of actor is smallest unit would be, as an example here, a function that needs to be called. And in the Dapr world, Dapr will make sure that that function is called with the right message. It's scheduled on a healthy instance where you don't have to care about the concurrency, the threading model, and anything else. So maybe this is a bit stretching, but this is like the smallest units in Dapr and the smallest units of work in Kubernetes. Now, what about if you want to execute this task periodically? That would be the recurring task. And in Kubernetes, that's the cron job. And it's very similar to job. It still has a job template, but in addition to that, there is a cron expression or schedule where it tells how often to run. So in this case, this container will run once every minute. So once every minute, Kubernetes will schedule a pod on one of the nodes and will make sure that this pod is run until completion. And that will continue whatever is the schedule, so the temporal event, then the event. In Dapr, the equivalent of that is today is the cron binding, which is defined on the right-hand side. Very similarly, it has a schedule element where you can use a cron expression. But the difference in this case is that rather than running the whole pod on a node, this is the pod that's already running, and it is every 15 minutes, the Dapr sidecar will perform an HTTP post call to your application at the endpoint you specified, which by default maps to the name of the job definition. In this case, it's scheduled. So you can see the two different ways, and you can decide whether you want the whole pod to be scheduled on a node, or if you have an already running application, but you only need a trigger to do something in your application, you can tell the Dapr sidecar to call the application. The cron binding today is stateless, but in the next version of Dapr, we have a new API, Jobs API, which basically will give you a stateful cron-like capability. And with that API, you can again trigger temporal events in your application. So that's the Dapr way of executing periodic jobs. So to sum up tasks, short-lived tasks, jobs in Kubernetes, right? They're scheduled on nodes. At the end, they're shut down. They're removed from the cluster. That basically represents the smallest finite unit of computation. You can use it to migrate the database or to some other kind of maintenance tasks that are run one-off or periodically. But the granularity is the container and the pod level. A cron job is an extension of that, which lets you schedule containers and pods on the nodes. On the Dapr side, if you want to run some small unit of computation, I would say the smallest unit is an actor, which can be small as almost like a function. And the Dapr sidecar will make sure that these actors are scheduled on your apps and triggered in a way that's considering failures. You can use actor reminders timers to schedule those interactions. You can use cron binding for stateless temporal task, or the new job API, which is coming, which will be a stateful way of scheduling tasks. So we are almost getting to the end. The next example here is with the distributed logs. And logs are really used to provide say, exclusive access to resource. Imagine if you have to, for example, pull files from a file system, or you want to provide exclusive access to database, to row, to table, or if you want to have consume messages sequentially, so you want to have only a single consumer, single thread from a single application that guarantees the ordering, right? And to do that in Kubernetes today, what you can do is, for example, you can run a pod with a stateful set as a single instance. Why stateful set? Because stateful set will give you stronger guarantees that even in the case of some kind of failure, for example, if a node becomes unresponsive, the Kubernetes control plane doesn't know if the node is healthy. The stateful set makes sure that that pod is not scheduled to another node until it's confirmed that the pod is not running anymore. So it has a stronger guarantees than a deployment on the number of instances. So you can use a stateful set, for example. You can implement something in your app to acquire a log using a config maps, or you can use the Kubernetes lease resource. The Kubernetes lease resource is one of the fairly new resources, which is used by Kubernetes control plane to make sure that certain control plane elements are running as a singleton and for other reasons. And you can write a Kubernetes operator that uses this resource and ensures logs. I would say all of these, including this custom distributed log implementation, are a fairly complex way for this problem. And Dapr simplifies that, right? There is the Dapr distributed log API, which is a simple way for your application to create a log and acquire a log. So in this case, I have two replicas of the application. You can see there's the main container of the application with the Dapr sidecar. And the idea is that if those applications need to get a hold of a log, the first one that acquires the log using a simple HTTP call becomes, in this case, the leader, the singleton, and can perform the exclusive access and perform the task it's supposed to do. So from this point of view, I would say stateful set can be used almost like a process level log if you want to make sure that there are only specific number of instances at most when you need some stronger guarantees than a deployment set. The least resource is really if you want to write your own Kubernetes operator. And if you want something simple, the Dapr HTTP log API can offer you that. What about configurations and secrets? In Kubernetes, right, we have config map and secrets, and Kubernetes will make sure that if you define those, your applications, right, will get the config map and the secret attached to it, available on a specific node. I won't go through the details what are the similarities and differences for this call, we can treat that config map and secrets are almost the same. How does that look like in Dapr? I would say probably you know by now, again, in Dapr, there is an API. It's called Configuration API, and it allows your application to retrieve configurations from different type of configuration stores, which can be relational databases, it can be cloud services, etc. And Secret API is very similar. It allows your applications to get secrets from external secret stores, so different kind of vault services. And in terms of similarities and differences, let's say when you're using config map and secrets in Kubernetes, you have to typically restart your pods and your application to get the updated config maps, especially if they are mounted as environment variables, right? And typically, these are scoped at namespaces, even though you can scope it to an application mounted as a volume, but typically they're at the namespace levels. Whereas with Dapr config API and secret API, your application can dynamically query those, and not only that, if the config changes, it can push the change to your application if your application is written in a way to react to these changes. These config map and secrets are also scoped per application. In addition, you can tell which specific, for example, which specific secrets your application can access, not just the whole secret configuration, but specific keys within that. And it abstracts the different configuration secret stores. Same way Kubernetes abstracts different kind of compute. That's the idea. So there is many more, let's say, differences and similarities, which I won't go, but hopefully this kind of gives you a picture how Dapr complements and differs from Kubernetes in which areas. One of the areas which I covered is resiliency, where Dapr gives you more. Dapr gives you resiliency between service interactions, between interaction with your application and external store, so mainly network resiliency, whereas Kubernetes gives you process level resiliency, making sure that certain number of replicas are running on a healthy node. And if that's not the case, Kubernetes will try to make sure that's the case. So these are some kind of differences. I won't go through all of these in this call. So let's get to summary. So if I were to sum up, right, I would say Kubernetes really enables the operations team to operate heterogeneous applications on any kind of infrastructure, and it does it with the consistent abstractions with pods, persistent volume services. On the diagram, there's the red Kubernetes layer and the compute infrastructure under it. Whereas Dapr really helps developers rather than operators. It helps to implement polyglot applications in any language, right? Using different kind of backing services. Think of third-party services such as cloud services, such as services that are running on Kubernetes, whether that's Redis, Postgres, message brokers, etc. And it does that with the consistent API. So Kubernetes is the API between compute, and the Dapr is kind of the API, the consistent API between your application and other backing services. That's the way I would describe them. And lastly, if you are curious about if you're starting with Dapr, we have a managed service. Conductor free helps developer to easily start developing and running Daprized applications on Kubernetes. It's completely free. And Conductor Enterprise, which helps companies who are running Dapr on Kubernetes, but more serious workloads, on production workloads, it helps you, again, install, operate, apply best practices, and monitor your Dapr installation on Kubernetes. Check those out. And I have a few links here. I do regularly blog on the Tigris blog around Dapr and Kubernetes. So you can check out the post there, sign up to our newsletter, and a few other links if you want to follow me and Tigris on Twitter.